So let's continue in detail about the hallucinations, reasoning errors and biases in generative AI. So as part of the syllabus, the learning level is K1, wherein you have to recall the definitions of hallucination, reasoning errors and biases in generative AI systems. Let's understand what exactly is hallucination in generative AI. So hallucinations occur when the large language model generates factually incorrect or irrelevant outputs. Hallucinations can mislead testers and compromise validity of the test results. Why? Because in case you are completely relying on the LLM knowledge or LLM model for the output, and you totally believe that the output and outcome will be completely correct and are using it, you might be getting the wrong answers, and you might, if you don't know the facts, don't know the concepts behind that topic. For example, you are searching a software testing topic, you are looking for a snippet for the automation code to do file reading, say for example reading the data from Excel sheet. If you get that code snippet and you don't know how that code snippet actually works, you won't be able to use it. Or in case the incorrect code snippet is being generated due to hallucination in the AI, you might not be able to understand whether it's correct or incorrect. So hallucinations mislead testers. If you are not sure of the output and you don't know that the output that has been generated is actually factually incorrect and irrelevant. So in software testing context, hallucinations can manifest as LLMs creating fictitious or irrelevant test cases, incorrect or non-functioning test scripts. In terms of automation, if you are relying on the test automation, it might generate the incorrect or non-functioning test scripts. It can create the test cases verifying the non-existent acceptance criteria. For example, I am trying to create the test cases for few acceptance criteria for a user stories. I have provided that in the generative AI prompt, but the output that I am getting is way more than that. The LLM has hallucinated and generalized the response to contain even more information or irrelevant information as compared to what I am expecting for that function or user story. So for example, if we talk about the requirement, if say requirement says system must support password reset via email, LLM might hallucinate and suggest the test cases for system also supports biometric reset. So anything related to password reset, whatever LLM has learned, the model has been trained upon, it might then go ahead and try to create answers which are even in the broader context or out of the context altogether. For example, I haven't provided any detail around the biometric reset, but LLM might hallucinate and provide details around that as well, whatever I haven't even asked for, which is misleading and is not in scope. Biometric is not in scope and I haven't provided it. So that's what hallucination in Gen AI is all about. The model will try to get you a lot more information or the information which is not in the context that you are asking for. So any such criteria or incorrect information, anything that gets out of the way or incorrect is what hallucination in Gen AI is all about. As a tester, you should validate each and every output very carefully from the generative AI in order to avoid any hallucinated result. Okay, so overly relying on the output or the generative AI output, just copying and pasting is not what you should be doing. Treat generative AI, any model that you are using, as one of your helping tool or helper, not completely relying on it. Okay, they are not foolproof and are prone to error, and any tool, any AI that will come in the market in the future will be prone to error. Okay, so make sure you do not overly rely on any of the output. Now if we talk about the reasoning errors that might be possible in generative AI. So reasoning errors occur when LLMs misinterpret logical structures, for example cause effect, conditional logic, step-by-step reasoning. If any of these are misinterpreted by the large language model, you will get reasoning errors. LLMs rely on pattern matching and not true reasoning. So in the LLM, the important thing is that you won't get true reasoning, because usually when you ask the questions, when you do the prompt, the pattern matching is what LLMs rely on. So it's not a true reasoning as a educated person or the knowledgeable person in that field or domain will do. So that's where reasoning errors are very common in generative AI. If you provide, a cause effect or conditional logic that Gen AI has to basically analyze and provide you the output, it might provide you reasoning error. And in terms of testing, you might get faulty logic in the test planning. You might get incorrect test case prioritization because of these reasoning errors, and you can get errors in the task requiring structural reasoning. So these are some of the impacts about the reasoning errors. If we talk about an example, for example, if I say a task prioritize test cases by risk, LLM might prioritize the cosmetic UI test cases over payment gateway test cases, which is not a correct logic, a faulty logic. Okay, so testers must spot any of these logical flaws, and you should be applying your own judgment to ensure that the output is accurate and there are no reasoning errors. And we'll understand these reasoning errors in the LLM models in the generative AI in some of the tools practically in the upcoming tutorial, wherein I'll show you that LLM will prioritize the test cases, we will prioritize the cosmetic UI test cases over payment gateway test cases, and that might not be completely correct. So you have to see that what is the prioritization, is it actually correct? No, will you take the basis or the base outcome that is provided by the generative AI, and then you redo the prioritization as seems correct or whatever is relevant in that project space. So that's the reasoning error. Now if we talk about the biases in Gen AI, very common. Biases are very common. Why? Because biases come from the data on which the model was trained. For example, if you have a small kid, treat a large language model as teaching small kid. So if you teach a small kid on the wrong doings, that you just say that whatever wrongdoings, slapping someone is really good from the very childhood, that child will believe that slapping someone is really good. So in that case, you are actually training the model, which is basically the training the child. If you just try to correlate or try to correlate the child learning and the model, so you are feeding in the wrong information, wrong data, wrong practices to the child, and the child might then pick and consider those things as good in future. Now because human beings have conscience, so the child might not be considering everything that you are saying as correct, but consider it as a machine, as a model, the large language model. When you feed in the wrong data and you say this is what it is, if you say feed in the image of the banana and you mark it as an apple, the model will then consider any banana image as apple, and it will say no, this is not a banana, this is apple, because it has been trained on the image of banana and you said no, this is apple. Okay, so that's where the biases come in picture. Within the data, if you feed in the wrong information or a particular sector of people or the demographics, so for example only English speaking information has been fed in the model, other languages will suffer. Okay, so biases arise from training data limitations. LLM outputs may favor certain perspectives or assumptions. So depending on how your data is, if your data is not proper or doesn't cover the holistic picture, then your model is in turn biased. Okay, in terms of testing, underrepresentation of non-English requirement, for example, skewed test data generation, biased refinement of acceptance criteria. If, say, for example, your model is trained on mostly English names, right? So in that case, generating a Indian name or any other nationality name for the test data and the addresses might not be possible with that model. So the data has to be proper in order to avoid biases in generative AI. Now, if we talk about the example, LLMs trained mostly on English data generate test cases ignoring localization need. For example, if you need a French and Spanish inputs, the model might not be able to do that. That's the biases in generative AI. So that's all about this tutorial. In the next one, I'll cover another topic of the generative AI certification course. Thank you. See you in the next one.